Well, hi again, this is Dr. Thomas, and in this presentation I want to show you how to use the Gauss-Jordan Elimination method on a 3x4 matrix. So let's review what the Gauss-Jordan Elimination method is again. First, you'll start with a system of equations, and then you'll write down the augmented matrix, which is just the numbers, the coefficients, and the constants. Then you're going to use a series of row operations to get a certain format. You can multiply a row by a non-zero constant, and then you can add a multiple of one row to another, and you can also swap rows. We're aiming for reduced echelon form. The rows of zeros are at the bottom. All the other rows have leading ones. Each leading one is to the right of the one above, and every column which contains a leading one has zeros every. So essentially, because we're dealing with a 3x4, it will look like this. So notice that the ones are in the diagonal, same as with a 2x3 matrix. Okay. And of course you're going to have some number here, let's call it A, some number here, let's call it B, some number here, let's call it C. And this is the X column, Y column, Z column. Or sometimes they refer to the variable 1 as X sub 1. Then the second variable is X sub 2. And the third variable is X sub 3. So those subscripts mean nothing. That's just an alternative way to write variables. Alright, let's get started with our first 3x4 matrix. The matrix is 2x plus 2y plus z equals 9. X plus z equals 4, and 4y minus 3z equals 17. So first thing you'll do is write this system as an augmented matrix. So we're only concerned about the numbers here, the coefficients and the constants. So the coefficients are 2, 2, coefficient for z is 1. We have 9. We have 1. Nothing's here for the y. Therefore, is 0. 1, 4. Nothing's here for the x. So it's 0. 4, negative 3, and 17. This is called the augmented matrix. Okay? Now, our objective again is to get this form. 1 0 0 0 1 0 0 0 1. Therefore, we want this number right here to be a 1. Now the easiest way I can see this becoming a 1 is just swap these rows. Now you could have subtracted these two numbers here, but I want to swap. You do whichever way satisfies you, but I want to swap these rows. I think that's the easiest way. Okay, so I'm going to swap row 1 and row 2. Row 1 swaps with row 2, and indicate swapping by the double arrows. Okay, so we have 1 now, 0 1, 4, 2 2 1 9, and 0 4 negative 3 17. Notice that we also got rid of an issue, because if we kept this 0 here, that would be a problem to keep a 0 here, because what we want is a 1 in the very center. Okay, we want a 1 here, not a 0, and we could not make a 0 1, so it would be best to swap the rows. Okay, so the next operation, and this is the pattern I follow. I make this a 1, then we're going to make this 0 0, then make this 1, and make this 0 and 0, and then make this 1 and make this 0 and 0. So we always make those leading ones first, and whatever's in that column, everything else has to be zeros. We make the leading one first, and then everything else has to be zeros. We make the leading one first, and everything else has to be zeros. So my next step would be to make this 2 a 0. And when you're trying to cancel out, when you're using row operations, you use the other row to cancel out the number that you want. So here we'll multiply row 1 by a -2 and add it to row 2 to get row 2. So here I'm only going to change row 2. Everything else is going to stay the same because I already have a 0 here, so I'm not going to change row 3 yet. So let's do -2 times row 1 and add it to row 2. We get -2 plus 2 is 0. -2 times 0 is 0 plus 2 is 2. -2 times 1 is -2. Add it to 1, -1. And -2 times 4 is -8. And add it to 9 is 1. So as you can see, knowing your rules for integers is very important once you get to matrices, because all you're going to be doing is adding, subtracting positive and negative numbers. So it's very important that you get these numbers correct, or else if you make a mistake, everything else below that matrix is wrong. Okay, so the next thing that we want to do is make this 2 right here a 1. So we always make the leading one first, and then we make everything else in that column a 0. So let's make this 2 a 1. Alright, so how can I make this 2 a 1? Okay, we can't avoid a fraction. Let's go ahead and make it a fraction. It may not be too bad. Okay, so let's do 1/2 times row 2 to give you row 2. Now the other option probably would have been try to make this a 0 first. You could, it might be best, but I'm gonna go ahead and bite the bullet and make this a 1, okay, by dividing by 2. So I'm gonna rewrite row 1 back over. I'm gonna rewrite row 3 back over. Okay, now if I just divide row 2 by 2, that's what 1/2 times row 2 means. We get 0, 1, -1/2, and 1/2. So we did get some fractions, but hopefully it's not too bad. Alright, next thing I want to do, since we got a 0 here, we want a 0 here. And to cancel out a number, make it a 0, we use the other row. Okay, so we multiply one of the rows by a non-zero constant. So we're going to multiply row 2 by -4. -4 times row 2 and add it to row 3. So -4 times row 2, we're going to add it to row 3 to give us a 0 here. So let me rewrite everything. Alright. Alright, so -4 times -1/2, -4 times -1/2. You do this, 2 goes into 4 2 times, so it's +2. And then you're supposed to add that to row 3. So 2 plus -3 is -1. Alright. Now let's multiply -4 times 1/2. So that's going to give us a -2 plus 17, which is 15. Okay, so this is where we left off at. This matrix is. So what will what should be our next operation? Well, we have the leading one here and everything else zeros. We have the leading one here and everything else zeros. Now we need to make the leading one here. How can we get rid of this negative one and make it a positive one? Well, we could just multiply row 3 by negative 1, right? So negative 1 row 3 to give us row 3. So I'm going to rewrite everything else. And for row 3, I'm going to multiply everything by negative 1, and that's going to give me the z. Alright, so this is x, y, and z. So now I know that z equals negative 15. So I got to figure out what x and y are. Now we need to make this a 0, and we need to make this 0. So let's go ahead and tackle this one first. Let's make this a 0. How can we do that using the other row? Well, we can multiply 1/2, positive 1/2 times row 3 and add it to row 2. And notice when we do that, it doesn't change this 1 here. It doesn't change the 0. If these things change to something else, that means we undid some work, and we don't want to undo the work that we've already accomplished. Okay, here we want this to be a 0, we want this to be a 1. So let's multiply 1/2 times row 3 and add it to row 2 to get row 2. So I'm going to go ahead and rewrite row 3 back over because it is completed. But for row 2, I'm going to multiply 1/2 times this and add it to this. So that'll be 0. 1/2 times 0 added to 1 will be 1. 1/2 times 1 added to negative 1/2 will be 0. 1/2 times negative 15. So 1/2 times a negative 15 is negative 15 over 2. But what are you supposed to do with that? Let's add it to row 2. What is negative 15 over 2? Add it to 1/2 because that's what's in row 2. We get negative 14 over 2, which is negative 7. So always reduce. Alright? And what we can do is already just go ahead and make this one a 0. What can you do? You can just say row 1 minus row 3. And that'll give us a 0. So row 1 minus row 3 to give us row 1. Because we want a 0 here in row 1. Alright? So row 1 minus row 3. 1 minus 0 is 1. And that's what we want. We don't want a negative 1 here. That's why I did not do row 3 minus row 1. Because that would have been 0 minus 1, which would make this negative 1. We don't want that to be a negative 1. We want it to be the positive leading one. Okay? So row 1 minus row 3. 0 minus 0. 1 minus 1. And then 4 minus a negative 15. What is 4 minus a negative 15? So plus plus, that gives us 19. So the answer is x equals 19, y equals negative 7, z equals negative 15. Alright? 19, negative 7, and negative 15. Now, how can you check to make sure that these answers are right? Well, you can plug these answers into the original equations, and you have to plug it into all 3 equations. For example, let me just do one equation. The first original equation was 2x plus 2y plus 2z, well, z equals 9. So if I plug in, we said x equals 19, and we said y was negative 7, and we said z was negative 15. Well, does that equal 9? That's what you need to check for all 3 equations. So let's see what we have. 2 times 9, 38, minus 14 here, minus 15. Does that equal 9? 38 minus 14, 24, minus 15, Yes, that does equal 9. So that checks for the first equation. But you need to do that for all three equations, and that's how you check to see whether or not your answer is correct. Alright, so let's put it in the augmented matrix. Since we don't have an x of 1, 0, -1, 1, 2, 4, -3, 2, 16, and 3, 2, 1, and 11. Now, again, our objective is to get this format here: 1, 0, 0, 0, 1, 0, 0, 0, 1. And in this situation, notice that that very first number is a 0, so we can't make that a 1. Therefore, let's switch some rows. So let's swap row 1 and row 3. I just need that to be something so I can get a 1 out of it. Okay? So let's swap row 1 and row 3. Now it becomes 3, 2, 1, 11, and then 0, -1, 1, 2 down here. And then our row 2 will remain the same. Okay. Great. Now we want this 3 to be a 1. Notice if I divide this row by 3, I'll get fractions right from the beginning. And usually I'm trying to avoid fractions. So another alternative could be to subtract 4 and 3, right? So let's say row 2 minus row 1. That would give me a positive 1. Row 2 minus row 1. So let's subtract. So we'll get 1, -3 minus 2. Again, that's -3 minus 2. That'll give us a -5. 2 minus 1 is 1. And 16 minus 11 is 5. And let's rewrite everything else over. Okay, our next goal should be to make this 4 a 0, because we want 1, 0, 0. So in order to use the other equation, we must multiply row 1 by -4 and add it to row 2 to get row 2. So 1, -5, 1, 5. That row doesn't change, so I'm going to rewrite the rows that do not change for now. And then we're going to change row 2. So -4 times row 1, -4 added to 4 is 0. -4 times -5. What's -4 times -5? 20. We're going to add it to -3. 17. -4 times 1 is -4. Added to 2, -2. -4 times 5 is -20. And add it to 16. -20 plus 16, -4. Alright. Now, we're looking at column 2. We want this number here to be a 1. Notice if I divide all of this by 17, I'm going to get some very ugly fractions. And I want to avoid it. I'm eyeing this row 3 here. I want to swap rows. Wouldn't it just be easier to swap row 2 and row 3 out, and then I can make that -1 positive 1 very easily. So let's swap row 2 and row 3. Alright, so we just swapped out row 2 and row 3, and in order to make this -1 a positive 1, all we really have to do is multiply this row by a -1. Okay, so I'm going to rewrite this row, this matrix back over, and then we're going to perform the operation of multiplying row 2 by -1. Alright, so again, this is where we left off from the last page. So let's multiply row 2 by -1, or negative row 2 to give us row 2. So only row 2 changes. Let me rewrite row 1 and row 3. So if I multiply -1 times row 2, all of the signs change. And that's what I get. Now, we want this -5 to be 0 and this 17 to be 0. It doesn't matter which one you do first, as long as you get them to be 0. So let's make this 17 a 0. So -17 times row 1 added to row 3. Well, -17 times row 2 added to row 3, to get row 3. Alright, so I know row 2 is not going to change. I'm going to try to do 2 steps in one. So the only row that's not changing is row 2. So let's change row 3 first. -17 times row 2 added to row 3. So 0 plus 0 is 0. -17 times 1 added to 17. 0. What's -17 times -1? Positive 17. But we got to add it to the -2, which would give us 15. -17 times -2 is positive 34, and added to -4 will give us positive 30. Alright, that's done. Now let's try to get this -5 here to be a 0. How can we do that? Using this leading one. Always use your leading one to make number 0. So we multiply row 2 by 5, and we're going to add it to row 1. And make sure that your other numbers in row 1 do not change. This 1 doesn't change. Okay. So 5 times row 2 is 0, added to 1 is 1. Good. We don't want that to become anything else but 1. 5 times 1 added to -5. 5 times -1 is -5. And when you add 1 to that -5, you get -4. Then 5 times -2 is -10, and added to 5 is -5. Now, what should be our goal? We have 1, 0, 0. We have our 0, 1, 0. We want 0, 0, 1. But we always we try to make the leading one first. Okay? More than likely you want the leading one first. Sometimes I skip over the leading one so that I can avoid fractions. But notice if we just divide row 3 by 15, or 1/15, the reciprocal, times row 3, that we won't deal with fractions. So it's best to divide row 3 by 15. So we'll get 0, 0, 1, and divide 30 by 15, you get 2. Alright, and I'm going to rewrite everything else back over. Now our goal should be to make this -1 a 0 and this -4 a 0. So we're going to do that in one step. Let me rewrite row 3 back over because it is completed already. So let's make this -1 a 0. How can we do that? We can just add row 2 and row 3, right, to get row 2. If we just add row 2 plus row 3, we can get row 2. So 0 plus 0, 0, 1 plus 0, 1, -1 plus 1, 0, that's what we want, and -2 plus 2 is 0. Alright? How can we get that -4 to be 0 using our leading one? So 4 times row 3 added to row 1 to get row 1. So 4 times 0 added to 1, 1. 4 times 0 added to 0. 4 times 1 added to -4. And 4 times 2 is 8. Added to -5 will give us 3. Alright, so therefore our answer is x equals 3 are x of 1, since we start out with x of 1, x of 2 equals 0, and x of 3 equals 2. Always check this answer by plugging these numbers into your original linear equations for all three linear equations to see if the left side equals the right side, and if so, your answers are definitely correct. So I hope this helps you with a 3x4 system of linear equations using the Gauss-Jordan elimination method.